Hello, we have been solving this past papers. So right now I'm going to do this additional mathematics paper 1. Okay, and this is May-June 2025 paper. So let's jump into start. Okay, so this is the first question here. Yeah, we are given a graph, a function y is equal to a function of x. And this diagram shows the graph of this equation. Okay, where a, b, c are integers, find the values of a, b, and c. You see this function y of x, the value of y becomes 0 at these 3 points, 1, 2, and 3. So this one is integer, this one is also integer, but this one is negative half. Okay, so these two integers corresponds to this b and c. Okay, so because if I say that x plus b is basically x plus 2, and this one is x minus 1. Okay, so here let me write it to x plus a as it is, and this is equal to y. So you can see that when x is equal to minus 2, this whole thing becomes 0, right? This corresponds to this point. Similarly, if x become 1, it corresponds to this point, everything will become 0. Now, this 2a plus 2x plus a, so this corresponds to this point. Okay, so you can see that 2x plus a is 0, so x is equal to minus a over 2, right? And we know that this x, the value of x is minus half, so you can see that a is equal to 1. So if a is equal to 1, then x is minus half, which is 2 over here. So if this will become y equal to 2x plus 1 and x plus 2 and x minus 1. Okay, so we found the value of a, b, c. A is 1, b is 2, and c is minus 1. Okay, I hope it's clear. Now the next question, next part is use the graph to find the values of x for which y is greater than or equal to 2. Okay, this is also interesting. You see, okay, let me erase this thing. Oh my goodness, how we can erase this one. Okay. Oh my God. Anyway, let's not do it. Okay, let me use some other color. Okay, you see, y is 2 over here, right? So this is the line y equals 2. So the function is greater than 2 when x is between this value and this value, right? So if x is between these points, then y is more than 2. Similarly, if x is more than this value, then y is more than 2, right? So you can see from here that let me write it here, that if x is from, what is this point? This point is minus 1.567. So from minus 1.7, and it is minus 1. So if x is less than minus 1 and greater than minus 1.7, and uh, sorry, or either x is in this range or x is more than 1.2, right? If x is in this range, for these values of x, the value of y is more than 2. Okay, I hope this is clear. Now, next question. This is also interesting. Find the value of k for which the equation has two equal roots. Okay, so if you remember, the roots are equal. Remember the roots of a quadratic equation, they are minus b plus minus under root b square minus 4ac divided by 2a. So if this part becomes 0, then the both of the roots will be equal, because one root is minus b plus 0 over 2, the second root is minus b minus 0 over 2. So they both are same. So both are same when this part is 0. So let's try to find this part b square minus 4ac. Okay, you see my a is 1 B is 4k and C is k plus 3. Okay, so B square means 16k square minus 4a is 1 and C is k plus 3. Okay, so I want this thing to be 0. Make sense? Okay, so 16k square minus 4k and plus, sorry, minus and 12 equal to 0. So let's try to solve this thing, find the value of k divided by 4. So it has become 4k square minus k minus 3 equal 0. Okay, so how can I find the values? Let's use quadratic formula. This is easy. So k equals minus b, so it is 1 plus minus under root b square minus 4 into a, so this is 16 into c minus 4ac. C is minus 3, so it becomes plus and multiply by 3 over 2a, so 8. Okay, so this become 1 plus minus, this is 48 plus 1, 49. 49 is 7 over 8, right? So when plus 7 plus 1, 8 over 8 is 1. When minus, so it is minus 6 over 8, so it is minus 3 by 4. So for these two values of k, this equation will have equal roots. Let's check. Okay, if k is equal to 1, my equation will become x squared uh, plus 4k and plus 4 equal to 0. And this is same as x plus 2 whole square, right? So of course, the both of the roots are x equal to minus 2. Okay, if I put a second value minus 3 by 4, so this equation will become x square and minus 3 by 4 will make it minus 3x, and when k is minus 3 by 4, so 2, it will become plus 2.25 equal to 0, right? Okay, let's try to solve this equation. Uh, so x equals minus b, so it's going to be 3 plus minus under root b squared minus 4 into 1 into c is 2.25 divided by 2a, so 2 on the 2. So you see, 4 times 2.29 will become 9. 4 times 2.25 will become 9. 9 minus 9 is 0. So again, this is gone. And I have 3 plus 0 by 2 is one root. And the second root is 3 minus 0 over 2. So basically, both roots are same. Okay. So it proves that these two values, for these two values of k, this equation will have equal roots. Okay, now let's quickly do this question number 3. Uh, Question number 3 said we have a polynomial where a is a constant. When divided by x plus 2, we get a remainder of 84. So let's see, if I divide this polynomial x3 plus ax plus 30, if I divide this thing by x plus 2, okay, what do I get? This is x square, so x cube plus 2x square. When I subtract minus plus minus, this cancels. I will have minus 2x square plus ax plus 30. Okay, next I will multiply by minus 2x. So it will become minus 2x square and minus 4x, minus 4x. So this is plus, minus become plus, this cancels, and I have uh, a plus 4 times x plus 30. Okay, so finally I will multiply it with a plus 4. Okay, so a plus 4 times x is a plus 4 times x, and then I have 2a plus 8. When I subtract, this will go away and I will have this negative, negative. So I will have negative 2a and 30 minus 8 is plus 22. And we are told that remainder is 84. So this must be equal to 84. So from here you can see that a is equal to 84 minus 22 divided by negative 2. Okay, so this gives me uh, 84 minus 22 divided by negative 2. So you get me negative 31. Okay, so the value of a is negative 31. It means my polynomial p of x, it is equal to x cube minus 31x plus 30. This is my polynomial, right? Okay, now see, what is the value of this function when x is 1? I'm just trying different values. So let's try 1. So this will become 1 minus 31 times 1 is 31 plus 30. You see, this is equal to 0. Okay, very good. It means that x is equal to 1 is one of the factor. Okay, x equal to 1 is a 1, or it means x minus 1 is equal to 0. So this is one of the factor of this thing. So p of x can be written as x minus 1 into some polynomial of x. Let me call it x, some other polynomial, right? How can I find this other polynomial? I can find this by dividing this whole polynomial, given polynomial x cube minus 31x plus 30 by x minus 1. Okay, so this will become x square. So it is x cube and minus x square. Subtract, this is plus, plus become minus, this is cancelled. So I have x square minus 31x plus 30. Okay, next would be plus x. It will become x square and minus x. Okay, minus plus plus minus, this cancel. So minus 31x plus x. So this is minus 30x plus 30. Okay, so it will go with minus 30. Minus 30 times x is minus 30x and minus minus plus 30. So this will be vanished. Okay, so what did we learn so far? We learned that this given polynomial p of x can be written as x minus 1 into x square plus x minus 30. Makes sense? Because when we multiply these two polynomials, we get this given polynomial p of x. Okay, now x minus 1, this is a quadratic expression and this is easy to factorize. Okay, and you can see easily that the factors are going to be x square and plus 6x plus 6, sorry, not x square, x plus 6 and x minus 5, because when you multiply plus minus minus 30 and yes, plus 1x. Okay, I try to remove this thing. Yeah, I don't know why my eraser is not working. Anyway, so these are the three linear factors. Okay, I hope you understand every part of this question, every part of all the question. If you like my videos, if they are beneficial for you, please subscribe my channel. Thank you very much for watching. If you ever have any question, you can always ask me in the comment section. See you in the next video.